Hello, this is Mr. Wynn, and this video is solving systems of inequalities in linear programming or optimization. So to solve a system of inequalities, you simply use to graph each inequality on a coordinate plane and find the overlap shading. That section is called the feasible region. The steps are simple. You just graph each inequality on the same coordinate plane, on the same graph, and check if there's any overlap shading. If yes, that area on the graph is the answer. You don't show domain or anything else. You just leave the graph and make sure that overlap area is really dark. And if no, you have to say no solution. They need to be really good at graphing, so make sure you graph the three types. The fastest is the cover-up method if it's linear in a standard form. Otherwise, we just stick with our transformations at AHK. You know, when you have y equals and you see the type is quadratic, so it's a U shape. It was vertically stretched by whatever. It was left whatever and down whatever, and then it was solid or dotted. Then one I haven't done yet, but is constant lines. Constant lines are when you have y equals a number or x equals a number. So single letter, single number. Those lines are either perfectly horizontal if it's y equals or vertical if it's x equals, and we'll see that in a second. So this first one says solve the system of inequalities. So the first one is x is less than 5. That is actually a constant. And since it's x equals, that's going to be a vertical line like this. And then it's dotted because there's no equal sign. So to draw a constant line, x equals 5, you just go to 5 on the number line. So 5 for x is somewhere over here. And we draw a vertical line dotted. Now this line, any point on this line has x value of 5, because if I had this, for example, that's 5, 0. This is 5, 1, maybe 5, 3, 5, 7, 5, 9. But x is always 5. X doesn't change, that's why it's constant. All right, then we have the next one. Actually, no. We need to shade. It's an inequality. For shading, you always use a test point. I'll pick a point on either side of the line. I like 0, 0's on the left side. I plug in 0 for x. There is no y plug 0 in for. That's okay. So 0 less than 5, that is true. So I'm going to shade the left side. All right, I'm going to do the same thing for the bottom. It's also constant because it's y, a single letter equals a single number. Now, because it's y equals, it is horizontal, it's sideways. And this one is solid this time. So for this, I'm going to go to 10 on the y-axis. That's 5, 10 somewhere over here. I'm going to draw a sideways line. Then I pick a test point. I'm like 0, 0. I plug in 0 for x. There's no x plug-in, but that's okay. With 0 for y, it's going to equal to 10. 0 is bigger than positive, that's false. So instead of shading the bottom side with 0, 0, I'll shade the top. Alright, so now look at the picture. Is there an overlap? So if you notice, our graph got cut into 4 pieces. So it looks like a plus sign. There's the bottom right that has no shading. The bottom left that has 1 shading, it's blue. The top right has 1 shading, it's red. But this top left from here, and keeps going to here, this rectangle shape is our feasible region because it's both blue and red. Alright, so that's the answer. Just leave it alone. Give the graph. Make sure it's really dark on that top left rectangle. But any point in there will make all inequalities true at the same time. Alright, we have this next one. This is no longer constants or standard form, so we graph, these are transformations. We know this one is linear. We know all linears are diagonal lines going upwards. There's no A, there's no vertical stretch or compress, but there is a K, that's up 7, and this is solid. Alright, so from 0, 0, I'm going to go up 7. I'll put a dot there. I draw a diagonal line, and I don't vertical stretch or compress it, leave it normal, 45-degree angle, and it's solid. Now this is still an inequality. I have to shade. I do a test point. So let's try 0, 0. 0 for y, 0 for x, plus 7. 0 is bigger than or equals 7. That's false. So instead of shading the 0, 0 side, I shade this top side. So they do like this. So right now we have the top part shaded. Shading for the bottom. It is linear. So the diagonal line going upwards. There's no A, so no stretch or compress. There's no H, there's no parentheses, but there's K, that's down 5. And this one's dotted this time. So from 0, 0, down 5, 0, negative 5, draw a diagonal line. I don't stretch or compress it, but it is dotted. We get this. All right, now, these lines are parallel. Just because they're parallel doesn't mean it's no solution or infinite solution. It depends on where we're shading. If I shaded above this green line, there would be overlap. If I shaded below, there'd be no overlap. So to figure out where to shade, you do a test point. I like 0, 0, because it's still obvious on one side or the other. 0 for y, 0 for x, minus 5. 0 is less than negative. That's false. So I don't shade the 0, 0 side. I shade the other side down here. So now look at the picture. Is there an overlap? There's no overlap, so you have to write no solution. You could do the circle with a slash through it, your choice. Alright. Now there could be more than 2 inequalities. There could be 3, 4, or 5, but the same idea applies. You're going to graph all of them and find the shading, and find the shading overlap for all of them. So before, there's 2 equations, we'd find the double overlap, double shade. But now there's 3 equations, we'll find the triple overlap, the triple shading. Alright, if there's no triple shading, then we say no solution. So the first one, that's in standard form, we should do the cover-up method. The cover-up method is plug in 0 for a letter. So I get 2x equals 6 and 3y equals 6 because I plug in 0 for x and then 0 for y. It's one step, just divide, you get 3, you divide, you get 2. And these are coordinates, 2 coordinates, the x and y intercepts. So this is 3, 0 because I plug in 0 for y, and this is 0, 2 because I plug in 0 for x. Now this sign matters. It doesn't matter when you do the cover method itself. That sign only matters when you're trying to figure out solid or dotted, or if it's, oops, where'd it go? Okay, it disappeared. Or if it's, what do you call it? If it's the test point, it goes, it's true or not. There you go. All right, so anyways, this is solid because there's an equal sign. So I'll put the 2 points. 3, 0 is somewhere over here. 0, 2 is somewhere up here. I connect it, solid. All right, I do a test point. I like 0, 0 is on bottom. 0 for x, 2 times 0, 0. 0 for y, 3 times 0, 0. Squared equals 6. 0 is bigger than 6. That's false. So I don't shade the bottom, I shade the top. So I shade this. Alright, then I do the next one. That is not standard form, but I can do transformations. We know that's linear. It's diagonal line going upwards. It's vertically stretched by 2. It is down 10. And it is dotted. So from 0, 0, I go down 10. 0, negative 10. I draw a diagonal line, but it is vertically stretched, so it's taller, and it's dotted. So here's this. I have to do a test point, 0, 0. 0 for y, 0 for x. Well, any number times 0 is 0, so that's why 0 is nice. 0 is bigger than negative 10. That's true. Should I shade this side? So right now there's an overlap, and you can see the top part because there's an x. Now grab this last one. Well, this one is a constant. It's y equals. Y equals is always sideways. And this one is solid. So I'm going to go to 7 for the y-axis. That's 2, 7 somewhere up here. Sideways line. And then I'm going to do a test point. I like 0, 0. 0 is less than or equal to 7. That's true. So I shade downwards. Now if you look at the picture, it looks kind of messy, but there's overlap. Where's it all 3 colors? Blue, red, and green. It's right here. So if you can tell, it's this right. It makes a little triangle. Alright, so all this right here is our feasible region. Any point in this area will make all 3 inequalities true. Alright, the last one is, can you tell if a point is a solution or not? Remember, you have the long way of graphing each inequality, doing a test point, find the shading, and seeing if the point is obviously in that overlap shaded area. That's a lot of work. The faster way and the safer way is just plug it in. There's no need to graph this picture. If you're plugging the point in, all the inequalities must be true to be in the overlap. But if even one is false, you just stop and say no, not a solution. So I plug in 1, 4 here. There's no x from, but this 4 is less than 5. That's true. Now again, 1 true is not good enough. It has to be all true. Alright, so I plug this in. So 4 for y, 1 for x. Make sure you absolute value correctly. Remember, you do the inside first. So 1 minus 2 is negative 1. Once it's a single number, it comes out as a positive in parentheses. Now the parentheses only matters, there's a number in front, so it's just positive 1 out. Then I combine 4 greater than equal to 4. That is true. Since both of them are true, then yes, this is a solution. If even one was false, it'd be no solution, not a solution. Yes, it is a solution. Again, no need to graph it here. Alright, so that's the first part. Then we have the second part of the video. That's the linear program optimization. Same thing. It's a method for finding the maximum or minimum values of a function or scenario. We use it all the time in real life for efficiency. with conditions, restraints, or constraints. Simple things are like minimizing your cost or maximizing your profit or minimizing waste or maximizing space. And the steps are very similar to what we just did. We're going to graph inequalities and shade, see if there's an overlap section, shading, that's the feasible region. Then we have 3 new steps. We're going to find all the vertices of that region. So for example, here I'd have to find this dot right here, this point, this vertice, and this vertex. 3 points to find. Now, usually it's pretty hard to find those points because our graph's not drawn in scale, but technically to find them, you just do a system of equations. We know that's where the red line and the green line cross, and you can find where 2 lines cross by doing elimination by hand or the RREF in the calculator. Alright, but once you find those points, you're going to plug those points into some equation, the end equation, the profit equation, the final equation, and then you use those numbers there. You find the best number and the worst number, and that's it. So, here's a problem. I'm not going to do the whole thing, but I'll just explain it. So here, each week Mackenzie can make 10 to 25 necklaces. So that equation is the necklaces must be greater or equal to 10, and the necklaces must be less than or equal to 25. So if you notice, right here, this is n is greater than or equal to 10, and this right here is n is less than or equal to 25. That's why we have this middle section shaded right now. Alright, the next one says she can make 15 to 25 earrings. So we know earrings has to be greater than or equal to 15, and earrings has to be less than or equal to 20 or 40. So you notice right here, this is the earrings, it's greater than or equal to 15, and right here, this is earrings less than or equal to 40. So now we're between these two. If you notice, we are in that rectangle right here, because that's where there's the overlap. Alright, but that's not our full picture. We have more equations, sadly. The next one says she earns a profit of $3 on each earring and $5 for each necklace. That's our profit equation. So that's this, which I'll come to it later. And the last thing is she plans to sell at least 30 pieces of jewelry. What to sell 30 pieces of jewelry? We know n plus e has to be greater than or equal to 30. Well, that's standard for our new covert method. I know n equals 30 and e equals 30. So that's the coordinate 30 comma 0 and 0 comma 30. So here's 30 0 right here. I'll use black. That's 30 0. And then 0 30 and 0 30 is out here. Right, but it's connected, it's dotted. I then pick a test point 0 0. If I plug in 0 0, that makes 0 is greater than or equal to 30. That's false. So I shade the top part. Alright, so what that does is it cuts our picture, our rectangle, into this shape. So it goes from here, it cuts off this corner right here. It goes here, 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 here. So now this red area is my overlap. So let me erase that and make it a little nicer. Alright, so now we're looking at this section. Once you have this, you got to find the points. Because anything here is the answer. But the 5 points are what's important. So I labeled it right there. All I do is plug those 5 points into our end equation, our profit equation. So let me plug in the first one. I'll try 1040. Alright, if I do 5 times 10 necklaces plus 3 times 40 earrings, that's 50 plus 120. That's 170. That point gets me 170 right here. But that's not the best option. I have to find the best option using those 5 points. Anything inside the feasible region would be not good enough. Alright, well, if you plug in all 5 points, you get all those numbers. The highest is 245. That's the maximum. The lowest is 110. That's the minimum. So this is the scenario, our best scenario that gets us the most money. So she wants to make 25 necklaces and 30 earrings. Now, I actually won't make you do the whole problem. I'll make you do this. I'll give you the first 3 steps done. I'll graph it for you. I'll find the overlap shading, and I'll give you the points. All you gotta do is plug those 3 points into the equation. So let me do that. All right, ta-da. So I plugged in 5, 20 into the equation. So 5 for x, 20 for y, I get negative 85. I plug in 20, 30. So 20 for x, 30 for y, I get 60. I plug in 30, 0. So 30 for x, 0 for y, and I get 450. So those are the 3 most important numbers. This is the smallest number. This is my minimum. That's the worst scenario. And then this is the biggest one. This is my maximum. This is the best scenario. Alright, so that's the best value. Alright, hope you enjoyed the video. Make sure to question class. See you soon. Thanks again. Bye.